The purpose of our project was to examine the growth of Spirogyra, a filamentous algae. While Spirogyra relies on many different nutrients, we focused on nitrate. Our hypothesis was that Spirogyra would grow best at about 0.01 moles of nitrate. We also wanted to compare this to different water sample environments, one standing and one running. This is our standing still environment of water that we're going to test to see if the different levels of nitrogen, or are there different levels of nitrogen between a standing environment and then a running water environment. So,
Here we are using the nitrate water test kit to examine the nitrate concentrations in the pond behind Stone Village at Bridgewater College, which was our standing water source. We also used the North River at Wildwood Park as our running source. We found that both sources had about 6 parts per million of nitrate, and there was no difference in nitrate concentrations.
we used a dissecting microscope to isolate Spirogyra from a mixed culture of algae provided by Dr. McCoy.
We formulated an algal broth and separated it into 5 different solutions in which we varied the nitrate concentrations, ranging from 0.002 to 0.02 moles of nitrate. We had 3 trials for each concentration. We inoculated these broths with about 150 milligrams of Spirogyra each and allowed them to grow for 2 weeks.
Calibration standards were made at the same nitrate concentrations of the algal broth. These were used in nitrate water tests and also used to standardize the spectrophotometer for measurements of the unknowns.
The nitrate concentrations from our algal samples. So we took 5 milliliters from each of our algal growths in the different concentrations, put it in these sample containers. You add a cadmium packet from the nitrate test and shake it for a minute. And then after it sits for 5 minutes, Logan's over here putting them into cuvettes to measure in the spectrophotometer. We have to go through this process for our calibration standards and our 5 different concentrations samples and each of the 3 for each concentration.
Okay, so now we're going to measure the absorbances of our sample 5, trials 1, 2, and 3. We're using a Curie 50, which can measure the absorbance. We've set our wavelength to 302, since that's where nitrate is absorbed at. And so I'll simply just put my cuvette into the Curie 50, shut it, and then press the read button, and it will give us an absorbance of our sample.
And just each of you get a chance.
Okay, so I basically just removed all the algae that we had in our standard 5 trial number 1, and I'm placing it in this weigh boat. At the beginning of our experiment, we took the wet weights of each standard and trial, and we measured their weight, and now I'm going to go ahead and take a final weight at the end of the 3-week period.
Our results showed that nitrate concentrations increased over a 2-week growth period. This increase was greater at higher initial nitrate concentrations. Algal growth was seen in lower concentrations, but at higher concentrations the wet biomass after 2 weeks of growth was lower than the initial wet biomass. This means that at higher concentrations, the Spirogyra died, which may have resulted in increased decomposition processes which ultimately increased the nitrogen concentrations.